Welcome back, Pre-Calc. I hope you all are well. Our objective today is going to be to divide polynomials. The kind of real objective for this is once we get into calc, it makes certain rational functions a lot easier to integrate. So I've got the checklist on the screen. You know what to do from here. All right, so this first example, we want to divide 8x to the fourth minus 5 by 2x plus 1. So here's how we're going to write it. Hopefully you recall this from Algebra 2. As well as the kind of analogous case of long division in elementary school, right? So I'm going to have 8x to the fourth, and then be sure to put your missing terms in. So notice I do not have a cubic term, so I'm going to put plus 0x cubed. I do not have a quadratic term, so plus 0x squared. I do not have a linear term, plus 0x. I do have a constant term, so minus 5. And it's going to be really helpful if we just kind of keep all our terms nice and lined up here, okay? So here's what we're going to start off with. We want to take the first term in the dividend divided by the first term in what we call the divisor, right? So we're going to go 8 divided by 2 is 4. And x to the fourth divided by x is going to be x cubed, right? Our power is going to go down by 1 when we divide. So I am going to have, I'm going to put, I'm going to get a cubic, I'm going to put it right over this guy. So 4x to the third, right? Okay, so we divide and then we multiply. So take this orange piece and multiply it, kind of think about distributing it through to the divisor of 2x plus 1. So 4x cubed times 2x, if we did it right, we should get our 8x to the fourth back, right? Now take this 4x cubed times positive 1, that's going to be 4x cubed, okay? So just like in elementary school, we divide, we multiply, and then our next step is what? Do you remember? Subtract, okay? Just be sure that you are subtracting this entire binomial, okay? So 8x to the fourth minus 8x to the fourth, that should always go away. So that's 0. Now 0x cubed minus 4x cubed is what? Minus 4x cubed. Good. So we divide, we multiply, we subtract, and then what is our last step? We bring down. So those are our steps of our algorithm. Now we repeat again. So now we're going to take our first term in the dividend divided by our first term in the divisor. So negative 4 divided by 2 is going to be negative 2, right? And then x cubed divided by x. We're dropping our power by 1 each time because I'm dividing by a linear term. All right, now I'm going to take this green part and multiply it through, distribute it through to my divisor. So negative 2x squared times 2x squared is negative 4x cubed. Negative 2x squared times 1 is negative 2x squared, okay? Now what's my next step? Subtract. So really make sure you're subtracting the green piece. If you want to actually distribute that negative, feel free. So these first two are going to cancel. Then I have 0x squared minus a negative 2x squared. So what do I have here? Positive 2x squared. Good. What's my next step? Bring down. So plus 0x. Okay. And we go again. So I've got 2x squared divided by 2x. What am I going to get there? Just a 1x, right? So plus 1x. Now I take the purple piece and distribute it through to this binomial, this 2x plus 1. So I'm going to get 2x squared plus x, right? What's my next step? Subtract. So these go away. Now I have 0x minus x. What do I get there? Negative 1x. What's my next step? Bring down the negative 5. Good deal. All right, can I go again? I can, because my degrees are the same, okay? Once the degree of what's left in the dividend is less than the degree of the divisor, that's when I've got my remainder, okay? So if I go negative 1x divided by 2x, the x's are gone, right? And I have just negative 1/2 or negative 0.5. however you want to think about it. Let me change my color. All right, so now I'm going to take the blue and distribute it to the divisor. So negative 1/2 times 2x is going to be negative x, and then I've got minus 1/2 or 0.5 there. Now I'm going to subtract. The x's go away, and I have a negative 5 minus a negative 1/2, so plus a 1/2. So I get negative 4.5, so I'm going to go negative 4.5 here. Okay, can I go one more time? I cannot apply my algorithm one more time because the degree right here is technically a 0. The degree of the divisor is a 1. So when the degree of the divisor is larger, I'm done, and this is my what? Do you remember? This is my remainder. And remember, I can put my remainder, I'm going to write it like this, remainder of negative 4.5. Okay, now my MATLAB is going to ask you to type these in a couple different ways. So before I write those two ways for you with example 1, I want to look at how you would do it just using real numbers. So go ahead and write this in your notes, 23 divided by 4. We know that the answer is 5 remainder 3, right? Okay, so there are a couple ways to think of this. I can think of this as 23 equals 4 times 5 plus 3. Or I could write it in fraction form and say, okay, 23 over 4 is equal to my quotient 5 plus my remainder 3 over my divisor 4, right? 5 and 3/4 basically. So essentially your dividend can be rewritten as your divisor times your quotient plus your remainder. Or you can take your fraction form and write it as your quotient plus your remainder over your divisor, okay? I know that's a lot of vocab, so let's go ahead and write that down. This is kind of your two forms once we go back to the polynomials. So polynomial form is that let's put the definitions with these analogous real valued problems so you can see that. So we've got that your dividend, so like this 23, is equal to your divisor, the 4, times the quotient 5 plus your remainder of 3, right? Or in fraction form that your dividend over divisor, so the 23 over 4 is equal to your quotient 5 plus your remainder over your divisor. All right, so there's a lot on the screen. I'm going to ask that you go ahead and pause and write down these definitions. So you go ahead and hit pause for me. So let's go ahead and write, or coming back to example 1, in polynomial form. I'm just going to put P for polynomial. That take that original polynomial, so 8x to the 4th minus 5 is equal to your divisor, 2x plus 1, make sure you have parentheses, times your quotient, so 4x cubed minus 2x squared plus x minus a half, plus your remainder. And since our remainder was negative, I'm going to go ahead and put a minus there. So minus 4.5, okay? That's how to rewrite this polynomial. Now, if I want to rewrite in fraction form, in other words, if I want 8x to the 4th minus 5 all over 2x plus 1, what do I start with? I start with the quotient, so 4x cubed minus 2x squared plus x minus a half. And then I'm going to take my remainder, so negative 4.5, and put it over what? Put it over the divisor of 2x plus 1. All right, force a pause on your screen. Can you go ahead and set up this problem for me? Make sure to put in zeros for your missing terms in your dividend. Hit continue when you have got it set up. All right, so make sure you got everything in descending order, zeros in for your missing terms, and then let's go ahead and start. So x to the 4th divided by x squared is going to be 1x squared, right? So I'm going to put that here. I'm going to take that orange piece and distribute it to this whole trinomial. So that's going to be x to the 4th minus 2x cubed plus 3x squared. What's my next step? Subtract. These cancel out, and I've got 0x cubed minus a negative 2x cubed, so what does that give me? Positive 2x cubed. When I subtract these two terms, those go away. I am going to put my plus 0x squared. And what's my next step? Bring down, so plus 0x. All right, can I go again? I can. My degree here is still higher than my degree of my divisor. So if I take the first term here, 2x cubed, divided by the first term here, what do I get? I get 2x. So now take the purple piece, distribute through to the trinomial. So you get 2x cubed minus 4x squared plus, 6x. All right, what's our next step? Subtract. Your first terms go away. What's your second term? 4x squared. And what about my last term? Negative 6x. Bring down your plus 1. Can I go again? I can indeed. So take your first term in here, divided by your first term in your divisor. And what do we get? We get a 4. So now take the green part, distribute through to your trinomial. So I'm getting a 4x squared minus 8x plus 12. Subtract. And the first terms go away. What's your next term? That's going to be positive 2x, right? What about your next term? Minus 11. Can you apply the algorithm again? You cannot. Now you're down to a degree that is less than the degree of your divisor. So this 2x plus 1 is your remainder. Sorry, 2x minus 11. Okay, so now let's go ahead and write this in polynomial form and fraction form. I'm going to let you try that on your own. Hit continue when you're ready to check your answer. All right, so your two formats are on the screen. If this is not what you got, you can change your answer in a different color pen. So obviously long division, it's not difficult, but it is somewhat tedious. The good news is if you're dividing by a linear term, which is really not uncommon in calculus, we can really simplify the process by using synthetic division. So if you'll remember, this is where we create sort of a matrix looking thing. And we take the 0 of the divisor. So if I'm looking at this piece, what x value would make that 0? It's going to be positive 3, okay? Then take just the coefficients of your dividend, filling in any missing terms with 0 still, okay? So it's already in descending order. So my coefficients are 1, 4, negative 5, and 5, right? Notice I had no missing terms. Okay, so now you can leave a blank row basically, and then our first step is to bring down this 1. Now we're just going to multiply and add it to fill in the rest of this. All right, so multiply the 3 to the 1, you're going to have 3. Now add straight across, you're going to have, or straight down, you're going to have 7. Now multiply the 3 to the 7. We get 21 here. Add straight down, we get 16. Multiply the 3 to the 16, you get 48. Add straight down, 5 plus 48 is 53. All right, so now we need to make sense of the string of numbers, right? So we took a cubic and divided by a linear, so my new power should be what? It should be a square. So we should end up with a quadratic for our quotient. So I get 1x squared, and then just keep going down in power, plus 7x to the 1, technically, plus, and this is technically 16x to the 0. And then what is this, 53? That's your remainder, right? So we've really simplified this algorithm of divide, multiply, subtract, bring down to just multiply and add. Because, and the reason we're adding instead of subtracting is because I changed the sign here, and the reason we can kind of eliminate that dividing step is because I'm just dividing by a 1x. So as long as I've got my coefficients properly here, these are going to take the step of that dividing part of the initial algorithm. All right, so let's have you try one on your own. Let's first just set this up using synthetic division. Once you think you got it set up correctly, go ahead and hit continue. So here's the setup. Once you've got the correct setup, go ahead and finish out the problem. Hit continue when you're ready to check your answer. All right, so I got x squared minus 2x minus 3. Notice that our remainder was 0 in this case. All right, let's try one last one. Let's do setup only. Then force pause on your screen. Go ahead and copy what I have for example 5. All right, we're back. Hopefully you notice that our divisor is a little bit different from what the format we need for synthetic division, right? We really need it to be x plus or minus something, right? Not negative x plus or minus a number. But I can deal with this pretty easily if I just multiply the top and bottom by -1, okay? So this is going to make my new numerator be negative 5x to the 4th plus 2x minus 1, right? And now my divisor is going to be negative 4 plus x, right? Or x minus 4, okay? So now go ahead and set this up. We're going to do setup only. Hit continue when you're ready to check your answer. All right, here's what we have for the setup, and then I am confident you can fill out, you can add and multiply from there. All right, you all, that is all I have for today, and I will see you next time.